Hello, everyone. Thank you for joining this presentation. The presentation today is entitled Conscious Showering, and in it, we're going to be having a look at how taking a more conscious approach to showering can help us really understand the cost and the environmental impact of the different showering solutions that are out there and how we might use them. So before we get into the sort of detail of it, what I want to do is just to invite you as the viewer to do a little bit of self-reflection on your own and your household's showering habits. The first thing I want you to think about is what sort of shower are you? How regular a shower are you? Are you somebody who showers twice a day, once in the morning, once in the evening, maybe three times a week? Do you shower at home? Do you shower at the gym because it's cheaper? What do you do? What is your sort of profile, would you say? What is your habit? Maybe you've never really thought about this before. Okay. Now, thinking back to perhaps your most recent shower, it might have been this morning, it might have been yesterday evening, who knows? Um, how conscious were you about how long you were in the shower for? Okay, was it a case you got in, you had no idea? In this reflection, what I want you to concentrate on is how long you were in the shower for. Those of you who perhaps have teenage children, it's not how long they were in the shower for, because I'm sure we're all very conscious of that. But yeah, just how long were you there for, and did you really pay much attention to that? Okay. So the third thing I want you to sort of reflect on was how conscious were you about the sort of the flow of water, the flow rate that was coming out of that shower head, good or bad? Did you pay it much attention? Did you adjust the flow during the shower at all, or did you set it on maximum flow and just get on with it? Okay. And finally, just want you to think, did you actually give much thought to how that hot water that you were using in the shower was actually being heated and where that fundamental energy actually even came from? Um, okay, so thank you for engaging with that first part. That first part is really to sort of get us to stop and think about this a little bit. What we've seen in the past is a lot of people shower regularly, but very few really give much credence or much thought to what's going on in the background, how long we're there for, the flow rate, or the energy source. And what I want to do today really is to start to unpick that a little bit and show how being more aware of this, both in what we specify but also how we use it, can reap significant environmental and financial benefits. Okay, so first, a little bit of context. Probably don't need to tell me to tell you that we are really facing sort of two pressing crises at the moment. We've got the cost of living on one hand, and we've got the climate emergency on the other. And for a lot of people, they see these two challenges as being kind of mutually exclusive. Somehow we've got to choose dealing with one or dealing with the other. We hear it in the news a lot. What I want to try and hopefully show today is how, by thinking more carefully about showering, we might be able to actually address both of these head on together and actually have benefits across both sides. The way I've structured this presentation is really around three key questions. First question is what? So, what's the situation? What's the background? Perhaps some of the context and some of the work that we've done at Triton. Then I want to look at the so what. Okay, so what all of that work we've done, what key learnings can we glean from this? And then the final bit is going to be the now what. So it'll be sort of a reflection and hopefully some key takeaways that you guys as builders or specifiers can take from this presentation and apply to your professional lives. Okay, so first a little bit about me. Who am I? My name is Daniel Lintel. I'm the sustainability manager at Triton Showers. I have a background as an industrial designer, so sort of design engineering. I've been at Triton for 5 years, initially in the sort of new product development area, but I've moved now across to being full-time sustainability. I've had a very long-standing passion for sustainability. It goes back to my university days, and my career background was in pharmaceutical drug delivery, so very much an evidence-based industry, and I've brought some of that into the work that I'm doing in sustainability. Okay, a little bit about Triton. If you may already know Triton, but in case you don't, we are a UK manufacturer. We started in a garage in Atherstone back in 1975, so we're coming up to our 50th year. And we now employ over 300 staff, primarily making showers and shower-related products that we sell to the whole of the UK, to Ireland, and a number of export markets as well. We are a carbon neutral certified business, have been for the last 2 years, and proud holders of the Made in Britain scheme, which we've been in for the last 10 years. Our purpose is simple. Our mission is to inspire everyone to shower sustainably because every drop makes a difference, and that is what is really underpinning everything that we're trying to do at Triton, both now and going into the future. Okay. We have some fairly ambitious net zero targets. We have set a net zero target across our full value chain. That's scope 1, 2, and 3, for those of you who are aware of the three scopes, of 2035. And we have a near time target of 2028. And really, success in this challenging endeavor is going to require collaboration and some good joined up thinking across many stakeholders, including the end users of our products, the people who shower at home, as well as builders, specifiers, architects, installers, those sorts of people. Ellie. So when we start to think about a shower's carbon footprint or environmental footprint, there are two things that we typically need to look at. We need to look at the shower's embodied carbon or carbon footprint, and that is the footprint associated with the making of the product. Okay, and that includes the transportation of all the componentry around the world, wherever they've come from, where it's assembled, where it's tested, where the transportation from the manufacturer, the end manufacturer like ourselves, onto the end customer, any maintenance that happens on that product during its lifetime, and then finally the disposal of it. Okay. The other side is the operational footprint. So that is typically the greenhouse gas emissions associated with the what we call the use phase. Okay, and that is generally regarded as the full lifetime use of the product. Okay. Looking at showering, typically the embodied footprint is about 5, maybe 10% of the overall footprint, and it's the operational side that is the significant proportion, certainly currently. And really, that makes it a real priority for our net zero plans. And it's that insight from the work that we've done that really has led me to this presentation to you guys today. So, the current focus in the UK, as we keep hearing, is on space heating because that's the number one source of household emissions. Okay. So we hear a lot about fabric first, and there's a real focus on insulation, and that's absolutely the right place to focus in on. This graph from Bayes back in 2019 shows that residential combustion, which is heating to heat our buildings and the water that we use in our domestic houses, is the second, or was the second biggest source of greenhouse gas emissions. What a lot of people don't realize, though, is that about 20 to 30% of that footprint is typically attributable to the water heating that happens in our homes. Okay, so why is water heating such a big deal? First thing I want to say is, for those of you who don't like maths or science or physics, don't panic. This is about as technical as I'm going to get. But what I want to share with you is this heat energy equation. And this equation basically is a way of calculating how much energy you need to heat up a substance, in our case, water. And there are three key things that we need in doing that calculation. The first one, we need to know the mass of the material that we're trying to heat up. Okay, in our case, that's determined by the flow rate of water and the duration. Okay. The second thing we need to understand is how much are we trying to heat that substance up by? Are we trying to heat water from 5 degrees to 40 degrees in winter, or from maybe 18, 19, 20 degrees in summer to maybe 38 degrees? Okay, that temperature change, that delta T, is important because it determines the energy. But then we have this wonderful thing called specific heat capacity. Okay, that is a function of any material. Every material has specific heat capacity. And it's a measure of how much energy you have to put into that material to raise 1 kilo of it by 1 degree. Now, for us, water is very interesting. Water is incredibly energy intensive because it has a very, very high specific heat capacity. It's why, as mammals, we sweat. It's why if you burn your fingers, you put it under the cold tap. That water is very good at taking a lot of heat energy away with it. It's often referred to as, we use it as a thermal battery. And that's great for lots of things in biology and in life. But when we're trying to heat water from 5 degrees in winter to 40 degrees to have that shower, it takes a lot of energy. All right. So the key takeaway from this slide is how much water we heat matters in terms of how much energy we need. But more importantly, where that energy actually comes from really starts to matter when we look at the climate crisis side of things. Okay, physics lesson over. Um, to try and help this, we've created a very simplified online water and energy savings calculator that end customers can go and look at on our website. If you're interested, there's a QR code at the end of the presentation. You can go and have a little look at that. But what you can see here is that, of course, the footprint and the costs are determined by how you use that, how many people are in your household, how often they shower, how long they shower for, and the type of shower that they use. And the calculator tries to estimate from those inputs, how much money it costs, or what it would potentially cost that family for a year's worth of showering. But it also starts to give some little prompts about, well, what would you save if you shower for, say, 1 minute less, and that sort of stuff. Okay. But that is a very simplified version of a much more detailed model that we've done, where if we really want to truly understand the footprint of showering, we have to dig a little bit deeper. We have to look at all the inputs and outputs, and to start to calculate their individual impacts. So with electric showers, it's fairly simple. You've got a cold water coming in, and you've got energy in the form of electricity that heats the water. The water is then used in the shower, then it's pumped back out and is treated. So we can look at the footprint and the costs associated with those. When we look at a mixer shower, however, it's a bit more complicated, because for a mixer shower, broadly, they have hot and cold water coming in. They consume no direct energy themselves. So we have to look further upstream into the sort of the hot water ecosystem in the house to say, well, how is that water being heated? And we've looked to model solar hot water systems, gas combi boilers, which are fairly ubiquitous at this current point in time, certainly in existing housing stock. We've looked at stored hot water, and increasingly we're looking at air source heat pumps and other heat pump technologies, and trying to model those. We look at it across a year's worth of showering, because, of course, the energy demand is very different in summer than it is in winter for heating water. And we look at all the sort of variables, the input variables, like how much does it cost you for the water supply and the gas supply, the electricity supply. What about the standing charges? And we prorata some of those, as well as some of those duty cycle variables that we talked about. Okay, so that's the sort of the work that's underpinning the modelling that we've done. The reason I'm sharing that with you is to give you an insight of what we've done. But what I want to do now is to try and give you some illustrated examples of what this means. So we're now moving on to the so what part. Okay. So first thing I want to do is just to give you a little bit of an illustrative comparison of three different showering ecosystems that might be in a house. And we're going to look at it for a 3-person household, where each person has 5 showers per person per week. We're assuming an average duration in that shower of 7.5 minutes and an average temperature across the year of 41 degrees. Okay, these are all based on the current price energy cap, as well as Severn Trent Water's current scheme of charges. Okay, so different tariffs will change these numbers a little bit, but hopefully it gives a good illustration. The 3 different ecosystems we're going to look at, an 8.5 kilowatt electric shower. We're going to look at a mixer shower running off an A-rated gas combi boiler, running at 12 litres a minute. And we're going to look at an air source heat pump with a COP of 3.5, so running at 350% efficient across the year. So this is going to be a sort of top-end air source heat pump. Okay, we're going to look at the cost, the water usage, and the carbon footprint of that year's showering for each family. So first of all, look at electric shower, about £340, using about 22,000 litres of water and 225 kilos of carbon. Okay, to set the carbon in context, 1 tonne of CO2e is the equivalent of about 4,300 miles driven in a mid-range family vehicle. All right, so hopefully it gives you a bit of a yardstick as to what 225 kilos of carbon might mean. If we look at the mixer shower coming off the A-rated gas combi boiler, you can see the costs are a little higher. The flow rate is higher, so you're using considerably more water in this instance, in this illustration. And as a result, the carbon footprint is the best part of 3 times higher than it is for the electric shower. All right. But now let's look at that same mixer shower, but running off the air source heat pump. Okay. So we've got a different source of energy. We're using electrical energy in this instance to heat the water. But because it's a lot more efficient, the carbon footprint is noticeably lower. Even though we're using more water, the costs are broadly comparable with what they would be for the A-rated gas combi boiler. Um, and that's partly because of the cost differential between gas and electricity. Okay, so hopefully you can start to see that the different ecosystems within the house for showering and hot water systems can have a significant bearing on what it costs the individual households to shower. Okay, and that was an illustration at that point. If we start to just look at the impact of flow and how flow reduction can potentially save carbon, water, and money. So this is something you only apply for mixer showers, not for electric showers. Okay, so same illustration, the three-person household as before. If they were to fit a flow regulator and reduce the flow rate by just 1 litre a minute, that would save enough water to fill 49 garden water butts of water. So there's 120 litre garden water butts. And the carbon footprint would be equivalent to 208 miles driven in a VW Golf, diesel VW Golf. That's just 1 litre a minute. If you can drop it by 3 litres a minute, so maybe going from, say, 12 litres down to 9 litres, they could save nearly £120 a year. And if you are going from 12 litres down to 9, I would argue you probably wouldn't even notice that reduction. Certainly not in flow, but you might notice £120 in your pocket. Okay, so flow rate can have quite a significant impact at a household level. Okay. Next thing we can do is, well, what if people just shower slightly shorter duration? With there's lots of things out there saying try and have a 4-minute shower or 5-minute shower. So for just 1 minute less, you can see some of the savings. It could be anywhere between £50 and £60, depending on your showering technology you're using. But saving considerable amounts of water and carbon as well, just by 1 minute less in the shower. And of course, they add up. Okay, so those first three or last three slides are really looking at a household level. Well, let's zoom out a little bit. As a country, we are committed to being net zero by 2050. So what happens if we start to scale up some of these savings? So first illustration is, what if 10% of UK households successfully reduced the flow rate from their mixer shower, and we're assuming here that it's connected to an A-rated gas combi boiler. So the top ones that you can get at this point in time. And we're assuming that flow rate reduction is a 3 litres per minute reduction. So maybe it's 12 to 9, as I said, or maybe it's 9 to 6, whatever. Okay. What would that mean? Well, over that course of a year, that would save enough hot water to fill nearly 14,000 Olympic pools. And that's the saving. That's not the total water usage. That's the water saving. 34 billion litres of water. It's almost incomprehensible. Collectively, they would save around £200 million. And from a carbon perspective, it would be the equivalent of taking over 200,000 internal combustion engine cars off UK roads. So, adds up quickly. If we can encourage people to shower for less time, in this instance, if 10% of UK households reduce their average shower time, by 2 minutes, and again, I've used the same illustration of the A-rated gas combi boiler for this one. If we could get them to do that, it would save nearly 30,000 Olympic swimming pools of water, be the equivalent of taking over 400,000 cars off the UK roads, collectively saving the best part of £500 million a year. Finally, if we look at the energy source, okay, and in this instance, I've looked at the electric shower, taken an 8.5 kilowatt versus a mixture shower connected to the A-rated gas combi boiler again, which is fairly representative of the options within the majority of households in the UK at the moment. We can look at the changes there. Now, it's worth noting that the carbon savings, if using an air source heat pump, or hot water supplied by an air source heat pump, providing it's well specified and you don't abuse the hot water system, those carbon savings would probably be similar for both the air source as well as the electric shower. In this instance, we've got over 37,000 Olympic pools of water saved, and be the equivalent of taking nearly 600,000 cars off the road. The cost savings are less than they were on the time, again, and that's predominantly because of the inequality between gas and electricity cost per kilowatt hour. All right, so hopefully that's food for thought. Probably made many of you stop and think, "Oh, I hadn't realised how much difference this could make." And you can see where our every drop makes a difference idea came from. Okay, so that was the so what. Now I want to just move on to the now what. So this is the key takeaways for you guys as builders, specifiers, and what have you. The first thing like you to take away is don't overlook showering in your net zero plans. There's a real focus in new builds and what have you, rightly on getting fabric first right and getting that insulation levels up. That's brilliant. What we're hearing from a number of leading house builders is by doing that, the number two source of emissions and cost in the household, i.e., hot water, suddenly goes to number one. So don't overlook it because you can make significant improvements for the householder as well as your SAP ratings and what have you by thinking carefully about showering and how it fits in. Okay, so consider those showering options as part of that whole house heating ecosystem design. If you're going air source heat pump, fantastic. Fit a mixer shower, but think carefully about the flow rate. Maybe fitting a flow restrictor on there so it's limited to maybe 9 litres a minute, or pressure reducing valves so that you limit the flow. So you don't undo a lot of that great work that you've done by fitting the air source or ground source system in there. Okay, so think of it in that whole house hot water ecosystem design. Wherever first, wherever possible, do fabric first. You hear this a lot. So if you can, consider things like wastewater heat recovery systems. Those systems are fantastic and can save, heading up to 70% of the energy usage associated with showering. They are brilliant, but they are best and most easily done during the sort of the build phase for new build. Retrofit is more of a challenge. So wherever possible, it's the decisions that you guys make in terms of the buildings that you are building that can have a big impact of the full lifetime impacts. Okay. Engage your residents, the customers that are buying this, around this, what role they can have and the benefits of shorter showering or flow rates, or what have you, but don't rely on that behavior change. Okay. Too many people go, oh, it's how the end customer is going to use it. Yes, that's true, but we can do a lot in how we set up those systems for them to use. Make sure they understand how any technology is going to work and any impacts that they need to do in terms of maintenance or what have you. Finally, really for a net zero future, it's the energy source that really matters. Fossil fuels are a thing of the past. Electrical forms of water heating are what I believe the UK particularly need to achieve the net zero future that we so desperately require. Okay. Hopefully that's been useful, and there's some key takeaways that you can take from today's presentation and start to apply in the work that you will do in your professional lives. If you want to get in touch, there's a QR code on the left. If you were interested in the energy savings calculator, there's a quick QR code on the right that you can do. But thank you very much for your attention today, and enjoy the rest of the conference.
Daniel, thank you very much for that extremely informative presentation. It gave us a lot of food for thought. Myself in particular, I did start thinking about my showering patterns. I am very aware when I'm showering of how much time I'm using and how much water I'm using. But I think the area for me to think more about is where the energy is coming from.
Good.
Not only to save costs, so to reduce my energy bills, but also because I would like to do more to help the environment.
Mm-hmm.
When it comes to the demands in the different showers that you mentioned, so electric, digital, mixer showers, could you explain a little bit about how these demands have changed and also your predictions around how they might change over the years to come?
Okay, I can certainly try. So I think historically, electric showers have been seen as a sort of a compromise choice. Okay, everyone's certainly in the recent years, marketing teams have been very successful at saying, we all want the spa experience at home. We want to be absolutely drenched with water. And whilst gas was very, very cheap, and through the sort of the meteoric rise of the gas combi boiler, we were able to have very, very large flow rates of water and being drenched by it, and we never really appreciated the environmental or economic costs of it because gas was so cheap. I think that all changed, with the war in Ukraine, when energy prices, both gas and electricity, but probably most noted by people for gas, really went up, and people became suddenly very aware of it. So, yeah, mixer showers and electric showers, they are sort of two different ecosystems, if you like. Okay, in terms of demand, as we move to a sort of net zero future, um, I think we will be, as a country, have to move across to electric forms of water heating. Okay, and I'm very clear about this, the definition there. I'm not saying it's the electric shower. It's electric forms of water heating. The electric shower is a very neat, compact way of accessing electric instantaneous water heating. Okay, and for some of the retrofit challenges that we have in this country, it's perhaps the ideal choice, because you're not having to rip out your entire house's heating system. For new build, um, there is a definite drive towards electrification. Okay, but that's where, if builders are thinking about the whole house heating solution and going for an air source or a ground source system there, then it's down to, well, do we want to have a hot water store, and how big is that going to be? Because you're heating water electrically for that. If you're going to do that, fantastic. Fit a mixer shower, but as I said, think about the flow rate. But actually, if space is tight and you don't want such a big store of water, or if you potentially even want to get rid of it entirely, then that's where the electric shower can start to come in. Okay, because it's more effective there. So, in terms of demands and what have you, I think there will be a need for both types of showering technology. Clearly, from a capital investment point of view, an air source system is tens of thousands of pounds. You can get the same sustainability benefits from an electric shower for, 50, 100, 150 pounds if you want to. But it's horses for courses a little bit. So I think, yeah, electric forms of water heating is the future. I think both technologies will continue to exist and will improve. Fundamentally, a mixer shower isn't going to address the climate crisis, because it's not consuming that energy. That's where we have to look at the other things. Whereas the electric shower has its feet definitely in that camp. Does that kind of help? Does that answer your question?
It does indeed. Yes, thank you very much. And just finally, I wanted to touch upon the going back to the fact that you mentioned that you're a carbon neutral certified business. I imagine this is actually an extremely complex process. So congratulations on the achievement.
Thank you.
I'm curious to know, if you could explain a little bit more about that complex process of reaching that stage, and some of the main challenges involved.
Okay, so the first thing to say is that carbon neutral and carbon net zero are not the same thing. Okay, but let's look at carbon neutral first. In very simple terms, for neutrality, you need to measure the emissions associated with something, and you define that scope. Okay, it could be for a product, it could be for an event, for instance. And once you've measured it, and there are protocols and internationally agreed ways of doing that measurement and assessment. You get a footprint. You then, once you know that the value of that footprint, you then purchase offsets, carbon offsets, which I'm sure we're all heard of, that neutralize that footprint. So, in our instance, our footprint for our scope 1 and 2 last year was 420 tons, there or thereabouts. So we purchased 420 tons worth of offsets to neutralize that. Okay. Offsets and carbon offsetting and neutrality is what we would sort of call beyond value chain mitigation. Okay, our primary focus is reducing our footprint. Okay, that has to be our primary. Through offsetting, we are taking responsibility for our historic emissions, because you always do it after the event. You measure something. In our case, we look at our fuel usage, our gas usage to heat the buildings, refrigerant gas losses, electricity consumption, those sorts of things, water, paper, waste on site, business travel, in order to understand our footprint for, let's say, last year. Once we know that, we can first of all say, are we on the net zero trajectory for the reductions we need to achieve? But secondly, we acknowledge that we were responsible for those, so we're going to invest in schemes to offset that and hopefully do some more good across the world. So that's neutrality. It's a nice thing. It's useful because it's forcing us to measure, and what they say, what gets measured gets managed. Okay. it's also giving us a really good kind of barometer to be able to say, well, if we do A or B, which is better? And rather than it be sort of subjective, we can now go, well, the carbon impact of doing A or B is whatever it is, the economic costs of A and B. So we can start to balance it. And businesses are very good with objective numbers. And frankly, I see CO2e, carbon dioxide equivalent, as like the US dollar of greenhouse gases. It allows us to compare lots of different things and go, what's the upside, downside, and what have you. And it's just part of accounting, really. And it's businesses are very naturally set up for it. So yeah, measuring your scope 1 and 2 footprint is relatively easy. The challenge is where you look to scope 3. Scope 3 covers the entirety of what's called your value chain. That's where the challenge lies, but that's where the real opportunity lies, particularly for manufacturing organizations. Okay, same with building companies and what have you. You know, they build those assets that then get sold to customers, but that building process and the use phase emissions of those houses that they build are part of their scope 3 footprint. So it's daunting. I always say it's hard, but it's not difficult. Okay, it's fairly simple. It's just it takes a different mindset, but with that different mindset comes opportunity. You know, most innovation comes from thinking about an existing problem in a new way, and I think sustainability and greenhouse gases, carbon in particular, is an opportunity space for those who want to be brave enough.
So, what would be your final advice then, Daniel, to those business people that are watching this session and perhaps haven't reached that point yet? They aren't quite carbon neutral certified, but they would like to be.
Yeah. So the first thing I'd say is don't be daunted. Go for it. Start small. Start to look to measure your scope 1 and 2 footprint. There are numerous organizations out there who will support you with doing that. Okay. It's not particularly expensive to do. Just to do the measurement. You don't have to do the offsetting. You can just do the measurement if that's what you want to do. You will almost certainly have all of the data that you need within your business systems. Yeah, you will know how much you've spent or on fuel, or how many liters of fuel that you purchase for your fleet vehicles. You will know how much you spent heating your offices and things like that. So you will have that raw data. You just have to gather it in the right way and put it into the right sort of forms and what have you. So that bit's easy. So start there, measure your scope 1 and 2, reflect on it, understand, become a bit more carbon literate. What does 1 ton mean? I mentioned it in the presentation. 1 ton of carbon, 4,350 miles in a mid-sized car. Okay, that starts to become more meaningful. Yeah, and you can start to do those trade-offs. But yeah, my single advice is don't be afraid of it, embrace it. It's not, in its fundamental terms, it's not that difficult. As you get to scope 3, yes, it's bigger, but scope 3 and reduction in scope 3 will require collaboration. So collaborate with others. Seek out people like us who've done it before and talk to us about that. Yeah, more than happy to share it. That's why I'm doing these sorts of presentations. All right. So yeah, be brave, go for it.
Well, thank you very much once again, Daniel.
It's my pleasure.
For joining us.
My pleasure. Hopefully that's useful, and enjoy the rest of the conference.